Today's lesson is about circles and specifically the proportion properties that circles have. So we're going to define segments of intersecting chords, secants, and tangents. And then we're going to look at some theorems that relate the lengths of segments determined by chords, secants, and tangents of circles. And then we're going to apply those theorems. So the first theorem we want to look at says that if two chords intersect in the interior of a circle, so that's inside the circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the other chord. Product means to multiply. So, for example, we have two chords here. We have chord BD and we have chord AC. They're intersecting at point E, and it's in the interior of circle O. So according to the theorem, the product of the lengths of this chord is equal to the product of the lengths of this chord. So AE, which is the first length of chord AC, times EC, which is the second length of chord AC, is equal to DE, the first length of chord DB, times EB, which is the second length of the chord DB. Our next theorem says that if you have two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and an external secant segment is equal to the product of the lengths of the other secant and an external secant segment. So here is an example of this one. So we've got two secants. We have secant AC and we have secant EC, and they are intersecting at point C in the exterior of circle O. So according to this theorem, AC, which is the length of the secant, times BC, which is the length of the secant outside the circle, has to be equal to EC, which is your second secant, times DC, which is the segment of that secant out in the exterior of the circle. Okay, so let's go ahead and apply one of those theorems. We're going to try to solve for X. And so these are two chords that are inside the circle, which means that the product of their lengths is equal to each other. So that means that 5 times 20, which is 100, has to be equal to 2x times 2x, which is 4x squared. So remember, we're trying to solve for x. So the first thing I'll do is divide both sides by 4. So I'll get x squared is equal to 25. And then I square root both sides, which means x is equal to the square root of 25, which is either positive 5 or negative 5. And since we're talking about length, it can't be negative 5. Our answer would just be 5.